Hello everyone, how's it going? So today we're going to be making another YOLO object detector video, and this is just a sequel to my previous series. If you go back to my channel, the 2-3 videos in the past which we have made, it's just a continuation of that. So today what we're going to do is run the YOLO object detector on a series of video files. So if you see here, I have this video and it shows different people, and it's a very colorful video with too much of information in it, and we're going to see how the YOLO object detector is going to perform in this video. So I ran this file and this is the output I'm getting. So you can see how intricate it is. I can't think of the word, but just see how many objects, how many items it's able to detect. I'm lost of words, and I can only describe how good this object detector is working. So we'll see how we can implement this on our own Python files, and let me take you to this video. So I would like you to look at this video to see how the YOLO object detector is installed or how it is configured in order to run. So do look into this video if you need help with setting up the YOLO object detector. Once you have set up object detector, I'm going to go into that old project file. So this was the project folder for that video. I'm going to just copy some of the files that we need, and we need this guy, the Python file which is running the object detector. We need the YOLO weights file, and that's the most heaviest file. It's about 250 MB. And we need the configuration file. We need the Coco names file. So we're going to copy that and we will paste this in our current project. It's going to take a few seconds and it will copy all the files. And let's rename this file the YOLO object detector file, and let's rename it with a smaller name, and I'll put it as YOLO.py, because we're going to be referencing this file from our main project. So main.py is the main driver, the main leader of the Python program, and that is the one which is going to reference the YOLO just to detect the objects. But all the reading the AVI file, reading the video, and then making the AVI file is all part of the main. And let me also go ahead and delete the output AVI file, because this is what we are expecting it to create out of this original video, which is the video.mp4. Now in place of video.mp4, you can also pass your webcam, so it can do live webcam detection, but I'm not going to do that because I'm running on a laptop and the speed is very slow. The FPS is probably 5 or 6. I didn't even look into it, but it's pretty slow and it's not going to give you that real-time effect that we are looking for. But as long as you can write it down and create a video file, that'll show you a seamless transition. But if you're looking for a more real-time experience, then you need a GPU and a better computer. Right now we don't have the money for it, but one day we will do the real time. Okay, now let's open the YOLO.py, and this is the YOLO object detector which we are going to be using, and this is the whole project that was shown in that video, the previous video. So I'm going to use the same code of the YOLO object detector and going to make it as a function. So let's make it as def object detector, and we will take a image variable. So I'll call it as img colon. So what this is going to do is I'm defining a function by the word object detector, and it's going to take an argument img, which is the image file that we're going to run for object detection, and everything in this code is going to be part of that function now, so that when I call YOLO, it's going to run this function for us. So let's indent everything so that it can be part of the function. I'm selecting everything in this file, and we are just going to indent this. So it has now indented and it is part of this function now. We can see that it's reading the weights file, it's reading the configuration file, the Coco names file, and it's also taking the argument img. Now in this original code, I was basically reading the image name name img image jpg, but since here we're going to pass the image as an argument from an outside source of the function, we can safely remove these guys. So we don't need, because we're not going to be reading it, and img is not going to be read, but instead img is nothing but the same img which we are going to pass as an argument to this function. So we can also safely remove this. Now this is done. So img.imread, I think everything is good. There is one last thing that we need to do, and in this case we don't want to write the output. Instead we're going to be return img, because once we are done with writing down all the images, once we are done with all detecting and drawing the images, I'm going to return that img. So this is where we are drawing the rectangles and we are putting the text on the image, and I think the text in this case was pretty big, and we will probably make it too small. We might make it 3 in size, and we'll give the thickness maybe 2, just because there are too many objects in that video, and that might cause too much of attention that we are not seeking. So y plus 30 maybe, because this configuration had changed just specifically for that video because we were using a bigger image, but in this case it's going to be a smaller 640 by 320 image. So I'm not so much going to be using the CV put text. In fact, we don't even need it, because it, in this case I'm only interested to see how many objects it's able to detect. But let's keep it for now, and we'll remove it if we don't need it. So let me save this file, and let me open up this main.py, which I've already made, and I've commented it for now, but I'll go one by one because it's difficult for me to remember the codes to rewrite it for you here. But I have written it down, and I'll show you one by one what each line of the code is going to do for us. So the first step is to import NumPy and import OpenCv. So OpenCv and NumPy are the only two libraries that we are using. In order to install NumPy on your Python, you can simply use pip install NumPy. In order to install OpenCv, you can use pip install OpenCv-Python, and that's pretty much you need in order to install both these files. Once we are done with that, we want to import this file which we created, the YOLO, because we want to call this function object detector from there. So we're going to be defining, and we're going to be calling this function from our main.py. So that's the reason we want to import YOLO, which is here, import YOLO. And now slowly one by one I'll show you what each line is doing. So cap is nothing but we're defining a capture variable which is using OpenCv's video capture function to read the video file, the original source file video.mp4. We're going to be using that, and we are using the capture variable to create that capture, which is going to help us read the frames coming out of the video. So every video is nothing but a sequence of images, a sequence of frames, and which are stacked on one after the other, and when it comes out in a continuous fashion, when it's displayed in a continuous fashion, it looks like a video, but video is nothing but a sequence of images. So this video capture is going to help us create that capture, so it can pull one image out of the other from the string of the video. So the next step is going to define the frame. So now each frame is going to come out of the read. And the reason I'm doing this here is so that I want to read the height and the width of the image. So the frame is nothing but the image. And in this case, I'm just doing cap.read, and cap.read is going to read the first frame. Cap.read is nothing but it's reading the frames. But if you put it on a loop, then it is going to read all the frames one after the other. but in this case I'm just reading it once so that I can use this frame to identify the height and width of the image automatically. I don't want to define my own height and width. I want to keep it same as the original image so that it doesn't look that I monitor or that I altered the video in any form except for the object detection part. So I want to keep the same height and width. That's the reason I'm extracting the original height and width. And layers is nothing but the channel information in that frame. We're not interested, but in order just to, because shape argument gives out 3 variables and we want to save them, but we are only interested in the height and the width of the image, the first image coming out of the video capture of the video. Now these two files, these 2 lines here, these are defining the video writer. Now what is the video writer? Like you have the video capture, which is reading the video out of your video file or also your webcam. OpenCv also provides us with a function called video writer, which helps us creating a video file. So it can take a sequence of images and then pass it to a video file. So 4cc is nothing but the codec information. Like if you have different types of video extensions like MP4, AVI, and etc. And they have these video codecs which define or which in-house the properties of that particular video file. And we use XVID for AVI files, and each extension has its own codec, each codec which is preferred. But we're going to be using the most widely used, which is more easy to open in any type of video player, and we are just using the XVID and AVI output. So that's the reason I'm using XVID video codec, and we are defining the video, and video is nothing but that video writer, which is going to help us write those sequence of images into the video file that we're going to be creating. So video writer and output.avi is nothing but I'm defining a name of the output AVI file, and 4cc is nothing but the video codec which we defined here. So 4cc is going to be, we're going to pass that here, and 20.0 is nothing but the frames per second. Frames per second, it means that if I'm defining 20, it means that for it's going to show you 20 frames per second, and our eye is capable of detecting 23 frames per second. So if any video is 23 frames per second or more or less in that range, it cannot predict the difference between 2 different images instantaneously. It would look like it's a seamless image, seamless flow of images. So that's the reason you want to keep somewhere in that range, and in this case we're using 20 FPS, and width and height is the same width and height that we extracted from this step here. Now we are done with defining the video writer. Once we're done with the video writer, we want to come back and now slowly read one image, one by one image from the original video file, and then take that image, pass it to the YOLO object detector, and then take it from the YOLO object detector, all the objects that are detected with the bounding boxes, the rectangles, the green color rectangles which we saw. Once those green color rectangles are formed, then you're passing that image back to your main.py and then saving it into your video output. And that is all going to happen in this while loop. So let me uncomment this. So I'm using cap is opened. So cap is opened is nothing but it's going to help the while loop know for how long it's going to be running. So unless and until this cap, which is the video capture and which is reading the video file, as long as it's opened, it's going to continuously read all the images from the video file, and once there are end of images, it is going to come out of the while loop. And like we did here, we just read one image frame, but here now we're putting in a while loop, so it's going to read one image after the other. So read Now ret is nothing but the result flag. We're not going to be using that, but OpenCV allows us to use that to help the developers know whether the frame came out successfully or not. Frame is the image again, and cap.read is just nothing but reading the image coming out of the video file. And you have output, and output is not, it's going to be the image that is going to come out of a YOLO detect objects. So I don't know what was the function. Yeah, I'm going to change that because originally when I programmed, I named it as detect objects, but if you see here, I named it as object detector. I'm going to copy this, and I'm going to change this function here because now the function name is object detector, and object detector is going to pass this frame, our original frame from the video file, and it's going to pass to this YOLO object detector function in our YOLO.py file, which is this. And after once all the object detector is performed, everything, all this code is run, and every object is detected, the rectangles are drawn, the text is written on it, it's going to return the img, the image, the processed image with all the rectangles on it, and we're going to save and extract that image and put it as our output. So the output image is the image with all the bounded rectangles, and we are now going to save that image in our AVI file. So video.write output is nothing but in the image here. I don't want you to confuse between this output and this output, because this one is nothing but a string, and it's just defining the name of the output file that we are extracting the image to. Let me rename this so that it doesn't cause any confusion. So output underscore img and output underscore img. These are both images which are processed, and now we want to put that into the video files, the output video files. Once everything is done, once all the video is done, now we want to release all the image, all the memory units. So the first memory unit is the capture, which is reading the original video file. We don't want that to be still extracting memory, so we're going to release that, and we're going to release any windows that are open, even though we are not opening any windows. But if at all it's going to create any errors, it's going to destroy all those windows. We don't need any windows. And we are also releasing the video and writer, so that once the release function is done, then the output.avi file is done. So we are letting OpenCV know that we are done with writing the video file, and you can close your video writer. So with that, we'll save this file, and we can simply go ahead and run this. So I have this here, list all the files, and we can run python main.py, and let's run that. So it's going to take a few seconds, even a few minutes, and we should hopefully see the output.avi come up here. Yes. So remember, we deleted the output.avi initially, but now it's slowly now creating that output.avi file for us. So this is a live action, and if I open this, it's going to show us some of the images, some of the frames that were extracted. Now it closed down because it only extracted 2 or 3 images so far, and if we give it a few more seconds, we can get to see a little more of the image. But let's see now. So it's detecting a few more, so it's coming up there, it's almost there. So it's going to take a few more minutes, and then the file will be done. And I'm not going to bore you with keeping this open for that long. We already saw what kind of an output it is. But with that, you know how the YOLO object detector can be applied to videos. You can use that for different types of data sets which are on the, I mean, there are street data sets, there are data sets where driving cars are driven, which are more used for self-driven cars, for those processing. So you can take those data sets and then pass it to the YOLO object detector to see how those objects are going to be detected in our Python file. So with that, those are some of the applications that we can help with, but more likely this was just going to be just a small tutorial to help us how we can read files from the video and then pass it to the object detector. Before I close the video, let me open this once again and see how far it has gone. So it's a 10-second video. It looks like we're already 2 or 3 seconds in the output. So yeah, it looks like about 2 seconds now. So with that, I'll come to the conclusion. If you like this video, leave a thumbs up, and if you like the things which I'm posting on this channel, consider subscribing. And this is more like a playground for me, where I'm going to be practicing. I'm going to be taking up more challenging applications to help my skill, more importantly, but also along the same line help you guys all to also come along the journey and see what we can achieve through this experiments. So with that, I come to the conclusion. Thank you and stay safe. Bye bye.